Uh, I have been a coach of the team from Valladolid, so I have some experience about this contest, and I'm going to make an overview of how you can use the online judge to learn. So the main objective of the talk is learn programming and also learn algorithms. But the good point is that we have an online judge that helps us to do self-learning. So the idea is to solve problems using the judge, and it's a kind of problem-based learning. So here is some kind of the steps that you should follow to solve problems. I think that everybody has participated in this kind of context is very aware of them. The first thing you should do is classify the problem. So you can choose the appropriate algorithm strategy. There are a lot of strategies that are known and are in the books of algorithms. So the first thing is to try the strategy that better fits the problem. Second important point is the data structures. So some of them are more suitable for one things and one for the others. I will explain a little bit about this. And next point is try to adapt to the limits of the problem. It's in time and also in space. Each problem has some limitations. The idea is that these limitations in the judge are make the contestants develop an efficient program. So we should try to find a good solution that fits that limits. Before sending our solution, we should test if it's a good solution, and also if it's not accepted in the judge, we should make some tests to find why it's not accepted. And finally, if you are having troubles, you must debug the program until you find the place that you should modify. So learning how to debug helps us to go quickly to the place that you should modify. I will make an overview of problem classification. I'm going to explain some of the strategies. These are some of the big ones. The first is brute force. This sometimes is appropriate for some problems. Maybe in a small contest you will have easy problems, so you can think of brute force sometimes. It sometimes can work. The next thing you can do is improve that solution using backtracking to reduce the space that you are trying to look at for the solution. Another big type of algorithms are the mathematical ones. So sometimes using mathematics is very easy to solve problems. Also the sorting, sometimes there are problems that can be solved using one known sorting algorithm. So everybody should know these algorithms. Also some of the problems are searching. Next ones are greedy algorithms. This strategy can also solve some of the problems. If the greedy algorithm doesn't work, or if it takes too much time, maybe you can try dynamic programming. Dynamic programming is more complicated, but the solution usually is more efficient. Other types of problems, the graph problems, and also computational geometry. These are big strategies. So let's take a look at some of them. The first one is to try all the possible candidates for a solution. this is very easy to implement and always finds the solution, but most of the times is not the solution that the judge is expecting. So maybe it's a first try to understand the problem, and also can be used to check if another solution outputs the right thing. But the drawback of this method is that it's takes a lot of time. That has a cost that it's proportional to the number of candidates, so it usually grows very quickly as the input of the size grows. Most of the problems in the judge use a very big inputs, so this strategy is not always working. So if you think that the input is small, maybe you can try, but it depends. If you are in a local contest, maybe this can be used, and maybe it's the easy problem in the set. But if you are in a regional or in a final, don't think about it and try another thing, because this is not the right one. So finally, I said before, it can be used to validate other things. So if you have a good solution, maybe the dynamic programming or so, if you're not sure if it's working, maybe an easy solution using this can help you check or find the thing is not working properly. This is the basic scheme of a solution using this strategy. The idea is that you are trying to check every possible solution. So you take the first one you can find, check if it's okay, and if it's not, you try the next one. So these are done until you find what is the appropriate solution. Or in some problems, you have to find all the solutions. So this also can help. A modification of these solutions is backtracking. The idea of backtracking is to build the solution in several steps. So if in the middle of the solution building you find that it's not promising, you can stop. Let's say some of the problems end up making a tree. So if you are in a point that is not promising, you can stop searching the branch of the tree and go to the other place of the tree. This is called the backtrack. So you go backwards and try another place to find the solution. This improves a lot the brute force algorithms. And an easy way of doing this is using a partial solution. So if the final solution is represented like a vector, the idea is to start picking elements of this vector, and at a given point you add another element to that partial solution and check if it's working. If the solution you find is promising, you can check if it's complete. So if it's complete, you find the solution, so you can print or do whatever has to be done. If it's not the final solution, you continue with the algorithm. But if you find that it's not a promising solution or invalid partial solution, you stop checking this branch and backtrack, removing this last element that is not appropriate, and try another one. This is the pseudocode of this idea. So the idea is also to try to check all the possible solutions. So you have in each step initialize all possible extensions, and while there are some extensions, you take the next possibility, and if it's acceptable, you add it to the end of the partial solution and check if you are at the end of the, or you have found a complete solution, you can show it, and otherwise you have to go to the next step in the partial solution. At the end, when you have tried all the elements in that branch, you should go backwards. So you need to remove that possibility from the solution and go over. This solution, if you take a look at it, it's using recursion. So using this procedure is called once and over again. So this is the way that you make up the tree of the searching space. So the tree is implicit, and you make it using this recursion. Talking about mathematics, so there are some types of problems you can find in the contest. Some of them are here. Most of the time, if you know that a problem is about something, maybe you can remember a past problem you solved and do it more easily. So some of the topics you can find here is the prime numbers, or things that when you calculate it are so big, so you need integer precision, so you need to use some kind of big integer. So maybe it's about permutations or number theory. Other things that usually appear are factorials or Fibonacci numbers, sequences, or things related to modulus. So the best thing you can do if you are going to train for this contest is try some of these problems, so you can have all the knowledge you need to, when in the contest you find some similar things to this. Greedy algorithms are other type of algorithms. So the idea is that they take the decisions in the short term. So they don't plan for the long time like other kind of solutions. So they take the information available immediately and try to find a better way and go over there. So without taking into account the future, they take the decision and go over. There are some problems that are suitable for this kind of solution and can be solved. Others are not. If you are going to use this, sometimes you end up in a solution that is not the optimal. So you are not finding the proper solution. So this strategy is used when you need to find an optimal solutions. There are some problems that there are a lot of solutions, but the problem asks you to find the better one. So these are the kinds of problems that can be used greedy algorithms. So they usually have some kind of function that provides the value of the solution, and using that, you have to check and find the best solution that gives the maximum of this value. An example of this kind of algorithms is the algorithm in the vending machines. When you take a Coke or something from a machine, the machine gives you the change. So the algorithm which is inside is a greedy algorithm that gives you the coins that have to be given to you in exchange of the Coke or the snack or whatever. They usually go with two sets. They try something and reject other candidates. And they also have a function to know if a candidate solution is a solution, and if it's feasible, but the most important is the selection function that selects which is the next candidate to try. This is the main point of these algorithms. This is the code that these algorithms usually have, and as I said, this is the thing you should create. If you have a problem in which you can think about a strategy of selecting the candidates, you can use these greedy algorithms. So you start, the solutions starts as an empty set, and you try the candidates, which is the C set in this code. And while you have some candidates and you haven't found the solution, you select one of them, remove from the candidates, and if it's feasible, you add to the set of the solution. You repeat this until you find a solution or not. So as you can see here, it's very efficient, these solutions, because this while executes the number of times depending on the number of candidates. And if this function is, let's say, efficient, this is a very efficient solution. But sometimes there are some problems that are not as easy as this one. So you have to use other strategies. The most usual strategy to use when the grading algorithm is not working is dynamic programming. There are lots of problems that fit in this strategy. These are the most known, the longest common subsequence. This is used in biology to check the sequence of DNA. So if you want to find some gene or something like that, you have to compare with a lot of sequences, and this kind of algorithms is the one that is used. In the DNA, there's a lot of genes and things like that, so there are big databases to search, so you need an efficient solution. Other related things are to find in a sequence of numbers a sequence inside that is all increasing numbers. A very known problem also is the edit distance. This is used, for instance, for detecting when someone is cheating or detect plagiarism. So you have something from your students and you want to check if it's taken from other place, like the Wikipedia or something like that. And these are the kinds of algorithms that are used to detect cheats from essays or whatever. Other known problem is the knapsack, 01 knapsack. This is very useful for logistics, for instance. You want to, maybe you have a ship and you want to put a lot of things inside, and this algorithm helps you know which are the best objects that you can put inside, or maybe in a lorry or something like that. So in logistics, this is very useful. You can optimize the things that you are taking in a lorry using this kind of algorithms. In some cases, the algorithm of given the change is not possible to solve as a greedy one, so maybe this dynamic programming is useful. Other known problems are the matrix multiplication, of finding a maximum interval sum in a sequence of numbers. The idea behind this strategy is the opposite of the divide and conquer. This divide and conquer strategy may repeat some subproblems, So if this happens, your solution is not going to be efficient. So dynamic programming makes a bottom-up strategy, building a table with known solutions for small problems. And with these small problems, builds the solution for bigger problems and goes up until you get the solution for the problem you were trying at the beginning. So the idea is use this to find these solutions to bigger and bigger problems. At the end, you also find the solution for all the subproblems, and this strategy works because of the optimality principle, which says that in a sequence of decisions, all the decisions must be optimal. If this is the case in your problem, you can use dynamic programming. So here's a small example in the knapsack problem. Most of the times you have to find a formula that helps you build this table. I'm not going to go into details here, but the idea is that you start filling the rows of the table, and to do this, you use this formula. So from the description of your problem, you think how to, using smaller problems, you are able to find the solution for the bigger ones. And when you have the formula, filling the table is very, very easy and efficient. Other classical problems are the graph ones. Here are some of the most usual things you will find. Traversal of the graph to find some roots. Maybe some float filling. This is the thing that happens when you are drawing something in the paint and you want to put something in one color. These are the kind of algorithms that are used there. Maybe you want to find how to go from one place to the other in the graph. So this is the classical Floyd algorithm. Other classical things is to find a spanning tree. Maybe you have a graph and you want to find a way to connect all the nodes in the graph. This is the better way. This is what the telecommunications company usually do when they want to connect the cities using fiber or whatever. Other classical problems is the bipartite matching, the maximum bipartite matching. This is, for instance, the classical, the marriage problem, or the students of medicine when they have to apply for the working at the hospitals. This is the more easy way to calculate the optimal solution. And well, other things like network flow or finding articulation points in a graph. Regarding sorting, these are classical sorting strategies, and sometimes these help you in solving problems. These first ones are the classical based in comparisons, and these two are the ones used for linear sorting. These last two does not work all the times, so you need to have limits in the input, but they are very, very quick. There are other kinds of problems that in searching or simulation, string processing, that you have to know to classify the problem and to start solving the problem. A related thing to the algorithm is the data structure that you are using. If you are trying to use, let's say, standard data structures, the best thing you should do is use a library. So if you are thinking in the context of the ICM context, maybe the STL is one of the best solutions, because C++ is one of the most efficient programming languages you can use. Maybe in Java also there are some good libraries. So the best thing is use one that is in the library and not building it from scratch, because it takes a lot of time. Here are the four most used data structures. The vector, which its main point is that it allows access to the position, a concrete position in constant time. A list, which allows the insert or removal of elements in any place in the sequence in constant time. Or the map or the set, that allows you to search things very, very easy or very, very quick. These last two allow you to do it in logarithmic time. Here's an overview of each of the four. When you use a vector in C++, you have the type of the things you are going to put in the vector. And as I said, the most efficient operation is the access to a concrete position of the vector. And also it's interesting to know that when you insert things in the vector grows in size, and this has a constant amortized time. It means that if you insert a lot of things in the limit, it will take a constant time to do it and to grow the size of the vector. However, if you want to insert an element in the middle of the vector, like this operation, you need to move some of the elements, so this takes a lot of time. It's a big O of n. The list has a better behavior when you insert an element and when you remove an element. So these operations are very efficient. There are constant time. However, if you are going to find a place in the vector or find something, you have to go over all the elements, so it takes a lot of time compared with the vector. The set, it's a place when you put things. This is the type of the things you are going to put in the set. They are usually implemented using some kind of search tree, so they provide a very efficient searching operations that are logarithmic. So if these are the main operations in a set, you insert elements, which is an operation that goes through the tree, so it's proportional to the logarithm of the elements, and also to find things, it's also efficient. A map is similar to a set, but it has all the elements in the map have a key and a value. So the key is the one you use to find elements, and when you find an element, the key has an information associated. For instance, if you are using a map for students in a university, this might be the ID of the student, and this may be all the information associated with the student. As which happens in the set, they have a logarithmic time for the access and for the insertion. So the only difference is that here the elements have a key value pair, and in the other one you only insert the full element. When you have an idea of which algorithm are you going to use, you need to take some calculations about the complexity. So you need to think if the time that your program are taking it's reasonable, and at the end the judge has a time limit. So if you are not having a good algorithm, you will get the time limit exceeded. So if this happens, what you should do is try to optimize your solution. The best thing is to start with the algorithm using one of the techniques we have shown before. If this is not working, the second thing you should do is try to find places in your code that should be optimized. So given the general solution you get, you need to find places that you can improve that solutions using the characteristics of the problem to reduce the complexity and find a solution that it's inside the limit of the judge. So here I have a table which tells us about which is the complexity and the time related with that complexity. So here we have the size of the problems, and here we have the time it gets to solve if we think that a problem of size 1 takes 1 nanosecond. So if you are in this part of the table, in the left part of the table, you have efficient algorithms. So if you have some of these, it's very likely that your problem is going to get in. But if you're having things like this one, or maybe factorial, or 2 power n, or things like that, you have to think about the size of the problem. If it's very small, maybe it can work, but if the limit of the problem in size is very big, you can expect a problem with the time, so you have to find other solution. The same is with the space. All the problems in the judge have a memory limit, so you have to think of how many memory are you using. So for instance, if you have a matrix like this, it's very easy to calculate how many bytes are you using. So you should think of this when you are trying to solve the problems in order to avoid this memory limit exceeded. However, sometimes wasting memory might be a good idea if it makes you develop the program more quickly. So you have to find a trade-off between the both, using a lot of memory or trying to use less memory, which will probably take you more time to make the code that is needed. Regarding testing, if your problem is not working properly, you should test it. The first strategy is black box testing, which means you have the program and you think of some reasonable inputs and check if the outputs are okay. A second strategy is the white box testing, in which you take a look at the inside of your code and try to develop test cases that go through each of the parts of the code and test the specific parts of the problem. Most of the errors usually appear in the extremes of the input values. So if the problem says that a variable has a limit, try to use that limits in the test cases to assure that your problem is working properly. In the case of white box testing, the idea is that you should try all the conditions in your problem and try to develop the test cases that go through all the possible paths in the execution of your problem. Because maybe there is some special case and it's going inside some kind of conditional that you haven't think about. So this test strategy tries to test all the possible paths of your code. This usually complement the black box testing. The idea is, as I said, try to execute all the sentences at least once to check if everything is okay and there's no strange things in your code. As I said, the boundary cases are a place that you should study carefully. So try using the limit and variables near the limit, maybe over the limit and under the limit. And also it's useful to use very big input for the problem, because in the judge all the inputs are very big to test the efficiency of the algorithm. Sometimes in the description of the problem you will find some tricky cases, maybe there is no solution cases or some special things, and most of the times you don't realize at first that this is in the description. So it's when the problem is getting grown answer, it's useful to read again the description of the problem to find these special cases. Another strategy you can try is use random test cases. Maybe you can create a small program which makes very big test cases, and even you don't have the solution, but maybe the program crashes with a big solution. So using these maybe random test cases or big test cases is a strategy that usually works to find problems in your code. A very good thing that you can also use is the tool UDebug, which I think it's explained this morning, I think. So it's very, very, very useful, because when you are working with a test case, you can get the output of this test case, and this helps a lot when you are going to solve a problem. And also this tool also provides you some random input. So I think this is very, very useful when you are trying to solve a problem and you are not able to do it. I think this is a kind of teacher that can give you some hints on how to solve the problem. All these testing things are getting more and more useful in software development in all kind of software, not only in problems for the judge. So maybe you heard about the test-driven development, which is used more and more in the companies developing software. The idea is starting with the test cases and get the code for the test cases and sometimes refactor the code. But the idea is start building software using the test cases and develop the code later. Mm-hmm. Okay. So the last point, yes, the last point is debugging. So if the problem doesn't work or the problem outputs an incorrect solution, the idea is that you have to try something in order to solve it. The most used strategies is using the print sentence in the code. This is very easy. So in the code you put in some places some print sentences outputting the content of variables with the idea to try to simulate a trace of the problem and try to find the problem. The more professional way of doing this is using debugger tools, most of them in the integrated development environments like NetBeans or Eclipse. So they allow you to use breakpoints, to view variables, so you can trace your code in a more easy way to find the problem. Sometimes there is a strategy that can help. I found the other day that it's called the wolf fence algorithm. It consists, let's say there is a wolf in some place, in some country like Alaska, and you want to find it. So the best thing you can do is put a fence in the middle and start hearing. If you hear the wolf in the left, you take the place in the left and repeat the strategy. So this, which helps you, is to divide the problem in smaller and smaller parts until you find the problem. So in the debugging thing you are working is you take your code, comment the half of the code, and try to find if there is something not going well in the other half. If everything is okay, you try it in the other half. So this is a kind of binary search that most of the times helps in finding that bug that makes your program crash or something like that. I think the computer is a little tired. Okay. So the last point or the key point of the idea of the judge is the self-learning. I think that the judge, it's a very, very good tool for self-learning. So if you are really interested in algorithms, the judge is the thing or the tool that you need. One of the key points is to select the right thing to do, because if you start with a very complicated thing, you lose the motivation and don't continue working. So the thing that you should do is to try to find easy problems, or at least problems that adapt to your skills. If you are a good programmer, you can try very hard things. So I think here you have some hints in the online judge. You can take a look at the number of submissions and the number of accepted ones. So if you find a thing that it's almost green, it's a good thing to start. And if it's red, maybe later. So start with the easy things. Other good things or you can try is the problem classification. So if you are not good at classificate problems, use the classification of the judge. I think I have a slide here. Yeah, if you browse the problems in the judge, there's a lot of classifications. I take one of them of usual lieu. So here you have the problems that you should use to start. Very easy problems. The problems that can be solved using the right data structure, or very brute force solutions, or other things. So this helps you to start working with the judge and finding the right thing to do. Because I think this is very important for self-learning, to start working in the things that you are able to do. Nor more easy or nor more difficult, just the right thing. Okay. Other good thing that you can find in the judge, or let's say the UHunt tool, is also a hint that helps you in finding the right problem. They use also an algorithm that shows you which is the best things you can do to try to work next. So this tool is, I think you should use for self-learning. I mean, the online judge, the UDebug, and the uHunt are tools that help when you are working alone. If you don't have a teacher near, so this can help you work in your own to learn the programming or algorithms. And the final advice, I think everybody knows, that practice and more practice is the only thing you can do. And the good point is that the judge, it's always working, it's 24/7, so it's not like a teacher that sometimes is not available. So in your weekend or one afternoon or wherever, you can take some time to improve your skills. So that's all of my talk. I don't know if there are some questions or something.